Across most of the animal kingdom, chronic obesity like we see in humans is rare in the wild. A deer does not spend the summer eating until it can barely run. A wolf does not finish a kill, wander back to its cave, and search for a snack. Even animals that gain fat for winter usually stop near the amount they need. Humans are different. We can eat a full meal, feel stuffed, and still make room when dessert arrives. We can know extra weight is hurting us, try to lose it, and then feel as if our own body is fighting back. That creates a strange evolutionary puzzle. Natural selection should push back against traits that stop animals from surviving and having young. Too much body fat can slow movement, strain joints, and raise the risk of disease. So why did evolution not give humans a clear stop button? Why does the body sound an alarm when weight falls, yet often stay quiet while weight rises? The easy answer is that people are simply weak or greedy. But that answer breaks down when we look inside the body. Hunger is not just a thought. It is shaped by signals moving between the stomach, fat cells, blood, and brain. Sleep, stress, medicine, genes, illness, and food can change those signals. So this is not only a story about choice, it is a story about an ancient survival machine trapped in a world it never expected. And the first clue is hidden in the very thing many people are trying to lose: body fat. Fat may look like useless extra weight, but to the body, it is stored fuel. Gram for gram, fat can hold much more energy than carbohydrate or protein. It is like carrying an emergency food supply under the skin. That sounds less impressive when a shop is 5 minutes away. But for most of human history, food was never guaranteed. A failed hunt could mean an empty stomach. A dry season could make plants disappear. In that world, a body that saved spare energy had an advantage. But that does not solve the mystery. If fat was useful, why did evolution not create a perfect system that stored just enough, then stopped? Why is the upper limit so loose? The next clue is in the brain. Your brain does not judge food by reading a nutrition label. It uses signals that are far older. Sweetness often meant ripe fruit or honey. Salt was needed for nerves and muscles. Fat carried a great deal of energy. When our ancestors found these things, eating them was usually a smart move, so the brain made them rewarding. Sweet food tasted good. Fatty food felt rich. Salt made food more satisfying. Memory helped people return to places where food had been found before. But nature kept those rewards on a leash. Fruit came with water and fiber. Honey was guarded by bees. Fatty meat had to be chased, killed, cut, and cooked. Salt was not poured over every meal. A person could want rich food, but wanting it did not make it appear. Today, those same rewards can be packed into one small snack. Sugar, fat, salt, soft texture, and strong smell can arrive together. The food can be eaten fast, delivering a large amount of energy before the body has time to say, "That is enough." Then the body does something even more frustrating. It protects the fat already there. Leptin is one signal in this system. It is released by fat cells. When someone loses body fat, leptin levels usually fall. The brain may read that drop as a warning. Hunger can rise. Food may become harder to ignore. The body may use a little less energy. A person who once skipped breakfast easily may suddenly think about food all morning. This is one reason weight loss often becomes harder after the first few weeks. The body is not asking whether the person started at a healthy weight. It notices that stored fuel is falling and prepares for trouble. Imagine a house with a loud alarm for anyone taking food out of the cupboard, but only a weak alarm for people putting more food in. Human weight control can work a little like that. The defense against loss is often stronger than the defense against gain. And now the puzzle becomes stranger. Why would evolution protect stored fat so fiercely, yet fail to place an equally strong ceiling on how much could be stored? For years, one famous idea seemed to explain it. It was called the thrifty gene idea. The story said ancient humans faced repeated famines. People whose bodies stored fat easily survived. People who stayed thin died. Over many generations, genes for saving energy spread. It is a neat story, maybe too neat. Famines do not only kill people because they run out of body fat. Disease, dirty water, war, and social collapse can matter just as much. Some famines may not have lasted long enough for extra fat to decide who lived. And humans do not all gain weight in the same way. That does not mean the thrifty gene idea is completely wrong. It may explain part of the story, but it may not explain the loose upper limit. For that, we need to look at predators. For a wild animal, getting too heavy can become dangerous very quickly. A slow gazelle becomes lunch. A bird carrying too much weight may struggle to fly. An animal that cannot climb, chase, hide, or escape may not live long enough to have young. That creates pressure from both sides. Too little fat risks starvation. Too much fat risks being caught. Then humans began changing the rules. They made tools. They controlled fire. They slept in groups. They threw stones and spears. They shared food and defended one another. They became better at spotting danger before it reached them. As humans gained protection from predators, one force that had limited body fat may have grown weaker. The lower limit still mattered. Too little stored energy could be deadly during sickness, pregnancy, winter, or shortage, but the upper limit may have faced less pressure. This leads to another idea called the drifty gene hypothesis. It suggests evolution did not choose extreme fatness because it was useful. Instead, once predators became less dangerous, genes affecting the upper limit of fat storage were free to drift in different directions. Some people may have ended up with stronger brakes. Others may have ended up with weaker ones. No one has proved that this is exactly what happened, but it explains something the famine story struggles with: why humans can have such different upper limits. Yet another question remains. If this weakness has existed for so long, why does widespread obesity appear to have been uncommon in the ancient world? Because the strongest brake may never have been inside the body. It was outside. Food took effort to find. Meals were less frequent. Seasons changed what was available. Daily life required walking, lifting, digging, carrying, climbing, and running. A strong appetite could push someone to eat whenever food appeared, but the world still limited how much could be eaten. Then, in a tiny slice of human history, that world vanished. Machines reduced physical work. Cars replaced walking. Screens replaced movement. Factories turned cheap ingredients into soft, rich food that could be eaten very quickly. Shops stayed open late. Fridges kept food ready. Advertising placed food in front of people even when they were not hungry. For the first time, the ancient brain could ask for rich food and receive it almost every time. The outside brake disappeared, and now, at last, the contradiction can be solved. Evolution did not shape humans to stay thin. It shaped us to be far more afraid of running out of energy. For most of human history, starvation and shortage were the more immediate dangers. A body that wanted high-energy food, stored spare calories, and resisted weight loss had a better chance of surviving the next bad season. Natural selection did not predict supermarkets, soft drinks, desk jobs, or delivery apps. It only shaped bodies that could survive and reproduce in the world that already existed. That is also why evolution has not quickly fixed obesity now. The modern food world is only a few generations old. Evolution usually works far more slowly. Obesity is also not controlled by one switch. It grows from many genes, hormones, habits, and parts of the environment working together. Many of its worst effects become more common later in life, often after people have already had children. That gives natural selection less power to remove the traits involved. This does not mean weight is fixed, or that choices do not matter. It means those choices happen inside a system with a strong hunger alarm, a powerful reward circuit, and a weak upper guardrail. Some people face a steeper hill than others. One person may feel full after a small meal. Another may stay hungry. One may move constantly without noticing. Another may save energy. Sleep, stress, illness, medicine, childhood, and income can shift the balance again. So when humans gain too much fat, the body is not doing something completely new. It is using an old survival plan in the wrong world. The system that once helped a family survive winter now meets food that never runs out. The alarm built to fear falling energy still works. The famine simply never comes.